Hi everyone, how are you all? Myself Nagappa, you are watching Appa Chemistry classes. Now our today's topic is chemical thermodynamics, which is important one. All the important model questions I am going to cover from this chemical thermodynamics. So from my Appa Chemistry classes, so far we had seen all the objective questions, all the numerical questions from the first year, all numerical chapters we had covered mostly, except groups. That also I am going to cover. So you try to watch till the end of this video, then you will get the complete all the different types of model questions from this thermodynamics. Is that clear? Now we'll see the first question. A system absorbs 600 joules of energy and does work equivalent to 400 joules of energy. The internal energy change is how much they are saying. We know that internal change in internal energy is equal to Q plus W from first law of thermodynamics. Now what they are saying here, Q is how much they are saying, 600 joules of energy is absorbed, that is plus 600 joules. Now W, work is does work. Does work means what? Which is doing work here? The system is doing the work. So work done by the system, so you have to take it as negative. So then what happens? Change in internal energy is equal to 600 minus 400. That is nothing but 200 joules it is. Is that clear? Now next question. So 1 gram of hydrogen at STP is expanded so that volume is doubled. Hence work done is how much they are saying. If the 1 gram of hydrogen at STP is expanded so that the volume is doubled. Hence work done is how much they are saying. We know that what? 2 grams of hydrogen. 2 grams of hydrogen gas, which is nothing but what? 1 mole of hydrogen gas. 1 mole of H2. 1 mole of hydrogen gas is nothing but 2 grams of hydrogen, which occupy how much volume? 22.4 liter at STP. At STP. But how much they taken? Just they taken 1 gram of hydrogen. Gas will occupy how much volume? That is 11.2 liter you will get. 11.2 liter. So initial volume is how much it is? V1 is equal to 11.2 liter. And V2 is equal to what happens? It is doubled. That is 2 times the V1. That is 2 into 11.2. That is nothing but 22.4 liter it is. Now what they are asking, the work done is how much they are saying. Work done is equal to P into P external into delta V. That is external pressure into V2 minus V1. Now you see here external pressure at STP condition, that is 1 atmosphere. 1 into V2 minus V1, that is 22.4 minus 11.2, that is nothing but 1 into 11.2 liter atmosphere it is. That is 11.2 liter atmosphere. We know that R value we know, that is 0.0821 liter atmosphere per Kelvin per mole. That is the R value in terms of liter atmosphere. R value in terms of joules it will be 8.314 joule per Kelvin per mole it is. Both are R values, just you equalize 0.0821 liter atmosphere. Here per Kelvin per mole will be get cancelled. So 8.314 joules it will be. Now for 1 liter atmosphere is equal to how many joules it will be? 1 liter atmosphere will be how much? That is 8.314 by 0.0821. If you do this one, you will get 101.3 joules you will get. 1 liter atmosphere. Here we got the 11.2 liter atmosphere. 11.2 into work done is equal to 101.3 joules it will be. So you will get the work done as how much you will get? You will get it as 101345 joules you will get. Point. Okay na? So that is 1.1345 kilojoules it will be. Okay, that is the work done in case of 1 gram of hydrogen gas. Is that clear? Yeah, next question. The molar heat capacity of water at constant pressure Cp they given. How much it is? molar heat capacity of water at constant pressure means Cp it is, that is 75 joules per Kelvin per mole they given. And what they given? Heat is supplied. How much? 1 kilojoules. 1 kilojoules, which is nothing but 10 power 3 joules it will be of heat is supplied. Then what is the weight of 100 gram of water? The number of moles of water will be how much it is? That is 100 by 18 it will be. Just you keep it as it is, which is free to expand. The increase in temperature of water is how much they are saying in degree Kelvin. Delta T they are asking to calculate. What is the relation between these? We know that Q is equal to N into Cp into delta T. So from this Q you know that is 10 power 3 joules. N is how much? 100 by 18. Cp is how much? 75 into delta T. So from this delta T is equal to, here 3 zeros, 2 zeros, 1 zero is left over. So 1 0, 10 power 1 into is nothing but what? 10 into 18 is nothing but 180 by 75. That is nothing but 2.4 it will be. 2.4 Kelvin it is. Delta T is how much? 2.4. Is that clear? Now when 1 mole of an ideal gas, monoatomic gas, is compressed adiabatically, the internal energy change involved is 24 calories. The temperature rise in degrees Celsius is how much they are saying. The temperature rise in degrees Celsius is how much? Delta T they are asking. They given the what? The change in internal energy, that is delta U they given, that is 24 calories it will be. Now what they given? Still N is equal to 1 mole they given. And still what they given? Of ideal gas, monoatomic gas. So we know that delta U is equal to N into Cv into delta T it will be. So in degree Celsius they are asking, small delta T we have to take. Now delta U is equal to N into Cv delta T. How you will get Cv? Cv for monoatomic gas. For F, Cv is equal to F by 2 into R kada. Now in this case F is what here? Degrees of freedom for monoatomic gas. For monoatomic F is equal to 2 it will be. Sorry, F is equal to 3. For diatomic gas, F is equal to 5. For polyatomic gas, F is equal to 6 it will be. That is Cv for monoatomic gas will be how much it is? 3 by 2 R it is. If you know the Cv, you can calculate the Cp, that is Cp is equal to Cv plus R. Cp minus Cv is equal to R. So you got the complete information about Cp-Cv relation and how to calculate degree of freedom also. Now you see in this case delta U is how much? 24. N is how much? 1. Cv is how much? F by 2 R. That is F is how much? 3 by 2 R. 3 by 2 into R value we have to take it. Just you take it as delta T. Now 24 is equal to 1 into 3 by 2. R value is, you take it as calories. R value in calorie 1.98. You just consider as 2. So into 2 delta T. So get cancelled. 3 8s. The change in temperature will be in degree Celsius is how much? 8. Is that clear? Now next one, 1 liter atmosphere is equal to how many joules? Just now I told you 1 liter atmosphere is equal to 101.3 joules it will be. So if you want to convert the joule into calories, we know that 1 calorie is equal to 4.182 joules it is. So or else simply you take it as 4.2 joules it is. Okay na? So from this if you want to calculate in calorie, so it must be divided with this 4.2. Then you will get in terms of calorie also. Now next one, calculate the work done in kilojoules when 1 mole of an ideal gas is expanded reversibly from 20 liter to 40 liter at constant temperature of 300 Kelvin they are asking. Now it is what they are saying, 1 mole of an ideal gas expanded reversibly. Whenever it is expanded reversibly, the work done will be in reversible process, the work done is equal to minus 2.303 nRT log of V2 by V1. Okay, so here minus 2.303, N is how much they given? 1 mole. R value should be taken in kilojoules, that is 8.314 into 10 power minus 3 kilojoules into temperature is how much they given? 300 into log of V2 is how much it is? 40 by 20. That is how much it is? Log 2. Log 2 is 0.3010. 2.303 into 8.314. It is 2 zeros, 1 0 get cancelled into 10 power minus 1 is left over into 3. So log 2 value is how much? 0.3010 it will be. Now you multiply all these, you will get the 1.73 kilojoules it will be. Work done is how much? 1.73 kilojoules. Is that clear? Now next question we are going to see. The dissociation energy of methane is 400 kilocalorie per mole and that of ethane is 670 kilocalorie per mole. The CC bond energy is how much they are asking. Now you see here CH4 dissociation energy, which is nothing but in methane how many carbon to hydrogen bonds are there? 4 carbon to hydrogen bonds are there. How many? Total of 4 CH bond energy is how much they given? They given as 400 kilocalorie. 400 kilocalories for the breakage of 4 CH bond. For 1 CH bond it will be how much it is? 400 by 4 it is. That is 100 kilocalories it will be. 100 kilocalories. Now what they are asking still? Ethane they taken. Ethane, that is C2H6. The ethane consists of CC bonds as well as CH bonds are there. In ethane, total of how many CH bonds are there? 6 CH bonds are there. Whenever it is dissociated, we will get the 6 CH bonds plus 1 CC bond we will get. Now, the total energy is how much they given? It is, the total energy is 670 kilocalories is equal to 6 CH bond energy plus 1 CC bond energy. We know we got the what? CH bond energy. How much? 100. 670 is equal to 6 into 100 plus CC bond energy. From this CC bond energy will becomes what happens? 70 kilocalories it will be. Is that clear? Now what is the difference between the heat of reaction at constant volume? Heat of reaction at constant volume is nothing but delta U and constant pressure, that is delta H. Constant pressure is nothing but delta H. Heat content which is measured at constant pressure is change in enthalpy. Heat content which is measured at constant volume is internal energy. We know that delta H is equal to delta U plus delta N RT it is. So from this delta H minus delta U is equal to delta N RT. What is delta N here? Delta N is nothing but number of moles of gaseous product minus number of moles of gaseous reactant. It must be gaseous product and gaseous reactant. How many gaseous products are there here? 2. How many gaseous reactants are there? 1 plus 1. That is 0. Delta N is 0 means the 0 into RT is nothing but 0. The difference in heat content which is measured at constant volume and constant pressure will be how much? It is 0. Now next one we will see. Next question. So given that C plus O2 gives rise to CO2 whose enthalpy minus 395 kilojoules they given. Okay. So S plus O2 gives rise to SO2 they given. And what they are asking? The heat of formation of carbon disulphide. How we are going to get this carbon disulphide? When carbon combine with 2 moles of sulfur, we will get the carbon disulphide. So it is a solid form. Whenever it is combined, then what happens? We are going to get the carbon disulphide as the liquid. Now, from the given data, you have to get this, you have to obtain this reaction by adding or by subtracting or whatever the method you do. Okay, na? Now you see here carbon disulphide is present in which reaction? This reaction. It is present, carbon disulphide is present on the reactant side. Just you reverse that reaction. That is 2SO2 plus CO2 gives rise to CS2 plus 3O2. Whenever it is reverse, the enthalpy becomes positive, one becomes negative, negative one becomes positive. 1110 kilojoules it will be. Now in this case, after that what we have here, there are no carbon dioxide, there are no sulfur dioxide, there are no oxygen at all. Now we have to cancel out those oxygen. In that manner we have to add, just you add the carbon plus O2 gives rise to CO2, because the CO2 gas will be get cancelled here. It is liquid, it is also gas. Here it is gas, it is solid. Now it is get cancelled, so change in enthalpy is how much? Minus 395 kilojoules it is. And after that what happens? The sulfur dioxide, where it is present? On the product side. Here on the it is on the reactant, here on the product side. But here 2SO2 is there, 1 SO2. Just you multiply this whole reaction with 2. 2S plus O2, 2O2 gives rise to 2SO2 gas it is. It is also gas, it is a solid one. Now then what happens? Its enthalpy will also, it is enthalpy for 1 mole of sulfur dioxide. Now in this case the enthalpy will be what happens? Minus 2 times the minus 295 it will be. Okay, so just add all these. So same terms which are present on the reactant and product side will be get cancelled out. Now here 1 oxygen, 2 oxygen, 3 oxygen, 3 oxygen get cancelled. Carbon dioxide get cancelled. What is left over? C plus 2S gives rise to CS2, liquid, so solid here. Now here the total enthalpy will be what happens? Add all those, plus 110 kilojoules minus 395 minus 2 into 295. You do this calculation, you will get the answer. You will get it as 125 kilojoules you will get. Is it clear? Now when 50 centimeter cube of 0.2 normal sulfuric acid is mixed with 50 centimeter cube of 1 normal KOH solution. Here 50 into 0.2 by 1000. It is what? Gram equivalent of acid. Gram equivalent of sulfuric acid. Combining with 50 into 1 by 1000 gram equivalent. Now whenever you are multiplying these two, 5 2s are 10 it will be, that is 1 by 100, that is nothing but 1 by 100 is nothing but 10 power minus 2 gram equivalent it is. But whereas in this case 0 get cancelled, 5 into 10 power minus 2 it will be. Now which is the smaller value here? This value is the smaller one. It is the limiting reactant. With respect to sulfuric acid, we have to calculate now here. Now we know that what? 1 gram equivalent of strong acid, 1 gram equivalent of strong acid is neutralized by they are asking in terms of heat energy mixed, the heat liberated they are asking in terms of kilojoules it will be. So 1 gram equivalent of strong acid is neutralized by 57 by strong base, 1 gram equivalent of strong base, and liberates 57.3 kilojoules of heat energy for 1 gram equivalent. For 10 power minus 2 gram equivalent, how much it will be? How much it is? Okay, that is for 1 gram equivalent 57.3. For 10 power minus 2 it will be 57.3 into 10 power minus 2 kilojoules it is. So in terms of joules you take, that is, it is nothing but 573 joules. Is that clear? Now here enthalpy change when 50 ml of 0.01 mole of calcium hydroxide reacts with 25 ml of 0.01 mole of HCl is dash calories. Given that enthalpy of neutralization of strong acid versus strong base will be how much? 13.6 kilocalorie per mole. Now here which is the stronger acid? Here HCl. that is 25 into 0.01 normality, because it is molarity equal to normality in case of HCl, it will be by 1000 it is. Okay, now then how much it will be? You will get it as 25 into 10 power minus 5 it will be. It is 10 power minus 2, 10 power minus 3, it becomes 10 power minus 5 it is. But whereas 50 into here it will be 0.02 it is. So it will be less value. Okay, now now it is the equivalent. Now here what enthalpy, what they are asking, the enthalpy change. The enthalpy change is equal to enthalpy of neutralization, that is enthalpy of neutralization into the concentration, whatever the concentration will be there, no, that is 2.25 into 10 power minus 5 it is. So enthalpy of neutralization is 13.6 into 25 into 10 power minus 5 kilocalories will get. So in terms of calories they are asking, into 10 power 3 you can do. So that is 10 power minus 2, it will be 25 into 13.6. You do this calculation, you will get the answer as, by doing this calculation, how much you will get? 3.4 calories it will be. Is that clear? Now if values of enthalpy of formation of ICl, Cl and I are respectively the given, the bond energy of ICl is how much they are saying. How you are going to get that ICl here? Whenever this chlorine gas combine with iodine in gaseous state combines, then we will get the what? ICl. Now what they are asking here, the bond energy of ICl they are asking. The bond energy, that is delta H in terms of bond energies, you will get it as bond energy of reactants minus enthalpy of formation of reactant minus enthalpy of formation of products it will be. Okay. So now what is the reactant here? Chlorine and iodine. Now chlorine is how much here? Chlorine is 121.34 plus iodine is how much? 106.96 minus 17.57 it will be. You do this calculation, you will get the answer as 210.73 you will get. 210.73, what it is? Joules it is. Okay, na? Next one. The heat of combustion of ethane, C2H4 is what? Ethene is 337 kilocalorie. If 5.6 liter of oxygen is used at STP, in the combustion, heat liberated is how much? So whenever the C2H4 is combust, that is in presence of oxygen, if it is burnt, we will get the carbon dioxide and water. When 1 mole of ethene is combust, we will get this much amount of heat energy. Just you take it as 2 here, 2 moles, 2 carbons, 4 hydrogens, 3 oxygens. So here change in enthalpy is how much? 337 kilocalories of heat energy is released when 3 moles of oxygen, that is 1 mole of oxygen volume is how much? 22.4 liter. So 3 moles of oxygen, it will be 3 into 22.4 liter oxygen is utilized for the combustion of this C2H4. We'll get 337 kilocalorie of heat energy. If we use only just 5.6 liter of oxygen at STP, so how much amount of heat is liberated? They are asking. 337 into 5.6 by 3 into 22.4 liter it is. How many times it is? 4 times. Now you do this calculation, you will get the answer as it is 1, 1, 2 and 3. Okay, 3 you will get. So that is, so how many times it will be? 4 2s are. So 4 2s are 8. So 3 is left over, 32, 28.08 you will get. Okay, now that is the kilocalories of heat energy will be released when you are using 5.6 liter of oxygen instead of 3 into 22.4 liter of oxygen. Is that clear? Now next question. Heat of atomization of ozone and oxygen are 25 units and 30 units respectively. What is the heat of ozonization of 1 mole of oxygen in the same units they are asking. What they are saying, heat of atomization of ozone. This is ozone. Atomization is nothing but ozone molecule changes to atomic form. So whatever the bonds we have, that bonds should be breakdown. So 3 nascent oxygen. Its enthalpy is how much? 25 units. Now next oxygen, what they are saying, 30 units. 2 atomization will be what? 30 units. Now what they are saying, what is the heat of ozonization? Ozonization is nothing but what? The process of preparation of ozone. We should get the what? Ozone here on the product side. On the reactant side, it should be oxygen. So then what we have to do to balance this? 3O2 plus 2O3 gives rise to, we'll get, that is upon, for 1 mole of oxygen, it is O2, 2 by 3 O3 it will be. Now in this case what happens? We know that enthalpy of reaction. What they are saying, what is the heat of ionization? That is enthalpy of reactant minus product, no? That is enthalpy of reactant will be what here? Reactant minus bond energy, that is atomization energy of product. And the atomization of oxygen will be how much it is? 30 minus products will be what? Ozone, that is 2 by 3 into ozone units will be how much it is? 25. You do this calculation, you will get the answer as 90 minus 50 by 3, that is 40 by 3. How much it will be? 1. So 10 it will be 13 point something you will get. That is the enthalpy change in terms of units. Is that clear? Now next one, 10 grams of argon gas is compressed isothermally and reversibly at a temperature of 27 degrees Celsius from 10 liter to 5 liter. Calculate work done for this process in calories they are asking. So work done will be, what happens? Work done is equal to, similar model we had seen, minus 2.303 nRT log of V2 by V1. Okay, so from this 2.303 into N argon, number of moles of argon will be 10 by given weight by molecular weight of argon. How much it is? 40 into, they are asking in calories, no? So R value should be taken in 2 calories into temperature 27 degrees Celsius, that is 300 Kelvin. Log of V2 is how much it is? 5 by V1 is how much it is? 10. Okay, 1 by 2 it will be. So that is 1 by 2 log 1 by 2, that is 2.303. Here get cancel. Here it will be 2. So by doing all this calculation, how much you will get? Around 100 you will get. How much it is? 100 calories you will get. By doing all this calculation, 100 calories you will get. Next question, heat of combustion of A is minus 10 kilocalorie per mole and that of B is minus 15 kilocalorie per mole. Mixture containing 3 moles of A and X moles of B on combustion released 105 kilocalorie of heat. What is the value of X? Now you see here, A is there solid which is on combustion with oxygen. Combustion is nothing but burning with oxygen. A metal oxide, we don't know how many moles it is. It is what? Minus 10 kilocalorie of heat energy is released. B is there which is also we don't know how many moles it is. Whenever it is combined, we will get the metal oxide of B will get how much it is? Minus 15 kilocalories. Now here what happens, when they taken the mixture contains 3 moles of A and X moles of B, that is 3 moles of heat of combustion of A plus X moles of heat of combustion of B. Okay, so these two are mixed on combustion, released the water by combining these two, and when they burnt, they got the what? 105 kilocalorie of heat energy. Just you multiply here 3 into minus 10 plus x into minus 15 is equal to how much it is? 105 kilocalories will be released. Now you see here it is heat energy release minus 105. Now in this case minus minus all will be get cancelled. Here 30 plus 15x is equal to 105 it is. 15x is equal to 105 minus 30. That is how much it is? 75. 15x. X is equal to what happens? So 5 it is. 15 5 is 75. Is that clear? Now next question. Now at 25 degrees Celsius delta G naught for this process, water liquid water changes to gaseous water. That is nothing but what here it is vaporization is given. Is 8.6 kilojoules. The vapor pressure of water at this temperature is, what is the vapor pressure of the water they are asking. Now for this reaction, first H2O in liquid state changes to H2O in gaseous state. Now for this reaction, equilibrium constant will be what happens? Gaseous H2O in gaseous state by H2O in liquid state. In liquid state, the active mass of liquid will be taken as 1. Okay, na? Its active mass is taken as 1. That is K equilibrium in terms of concentration. If you have taken H2O, it will be. If you are taking Kp, it is partial pressure of water. It is partial pressure of water vapor. Okay, na? Vapor pressure of water it is. Vapor pressure of water, how you will get? Total pressure into that you will get, no? Now we know that what delta G naught is nothing but at equilibrium. It is reaching at equilibrium, delta G becomes 0. Then delta G naught is equal to minus 2.303 nRT. Okay, na? It is RT. N is it is standard condition, that is 1 mole. 2.303 RT log of K equilibrium. Now here what happens? Delta G naught is how much? 8.6 into 10 power 3 joules it is. 2.303. R value is 8.314 joules into temperature is how much? 25 plus 273. That is 298 degree Kelvin log of partial pressure of water it is. Vapor pressure of water it is. Okay, so you do this calculation, you will get the vapor pressure of water as 24 torr. You will get 24 torr. Is that clear? Now next one, for a liquid, enthalpy of fusion is the given and molar entropy change is 5.26 calorie per mole. Calculate melting point of liquid in degree Celsius is. They are asking calculate the enthalpy change, enthalpy of fusion they given. Enthalpy of fusion is how much? 1.435 into 10 power 3 calories per mole. Now what they given still? They given the entropy change. Delta S is equal to how much they given? 5.26 calories they given. We know that T delta S is equal to delta H, enthalpy of fusion, is equal to entropy T into delta S it will be. Okay, because at fusion temperature Gibbs free energy is equal to 0. So from this T is equal to enthalpy of fusion is how much? 1.435 into 10 power 3 by 5.26 it will be. So per Kelvin it is. Okay, na? Per 1 Kelvin, calorie per Kelvin, per 1 Kelvin. So if you do this calculation, you will get how much it is? 273 degree Kelvin you will get. Approximately 273 degree Kelvin you will get. That is nothing but what? 273 degree Kelvin is nothing but 0 degree Celsius. 0 degree Celsius. Is that clear? Next one. Calculate the delta H for the isothermal reversible expansion of 1 mole of ideal gas from initial pressure of 1 bar to final pressure 0.1 bar. Initial pressure is 1 bar. Final pressure is 0.1 bar at constant temperature at 273 Kelvin. isothermal reversible expansion, that is delta U is equal to 0. Then what happens? Delta H, that is nothing but Q is equal to minus W. Is it or not? Delta H is equal, delta U equal to 0, Q is equal to minus W. That is work done is equal to 2.303 RT, nRT log of V2 by V1. It is nothing but P1 by P2. So V2 by V1 or P1 by P2. That is 2.303 into 1 into R value they are asking in constant. So they take you take the what in joules, 8.314 into temperature is how much they given, 273. Log of P1 is how much it is, 1 bar. So P2 is how much it is, 0.1 it is, 0.1. That is nothing but, it becomes 10, log 10 is 1. That is 2.303 into, just you take it as in terms of calories. So that is 2.303 into 1 into 2 into 273. You do this multiplication, you will get the answer. Log 10 you will get, no, log 10 is how much it is, 1. So you do that calculation, you will get the answer. Now next one, for the reaction Ag2O gives rise to 2Ag plus half O2, delta H, delta S and T they given respectively. Free energy change of the reaction will be, we know that delta G is equal to delta H minus T delta S it will be. Delta H is how much they given, 40.63 kilojoules it is. They given here it is joules. Now you convert into joules, 10 power 3 joules minus T is how much, 373 into 108.8 it will be. So you do this calculation, you will get the what, delta G is 0. When delta G is 0, then it is said to be at equilibrium. The reaction is at equilibrium. Or else you can do in another way also. That is T is equal to delta H by delta S. If this T is equal to this 373 Kelvin, then that delta G will becomes what, 0. Okay na? So because if it is equal to this 373, if multiplied we will get the what, delta G is 0. Delta G is 0 means it is at equilibrium. Not standard Gibbs free energy, only Gibbs free energy. Now a quantity of 4 moles of an ideal gas at 20 degrees Celsius expand isothermally against a constant pressure of 2 atmosphere from 1 liter to 10 liter. If entropy change of a system in calories they are asking, entropy change will be given as 2.303 nr log V2 by V1. V2 by V1. Whenever it is ideal gas expand isothermally, okay na, isothermal process, then what happens here, 2.303, that is work done, internal energy will be 0, delta H is equal to minus W. That can be taken as delta H, in place of delta H we can take it as delta S there. So there what happens, 2.303 into n value is 4, R value in calories they are asking 2, log of V2 is how much it is, V2 is 10 by V1 is 1. Okay na? So then it is 8 into 2.3 nothing but 8 3 is a 24. So 8 2 is a 16 plus 2 18.4 calories it will be. Delta S will be how much, 18.4 calories. For a liquid, enthalpy of fusion is 1.435 kilocalories. Enthalpy of fusion is how much they given, 1.435 into 10 power 3 calorie per mole. It is repeated question. So in different way they are asking. Molar entropy change, how much it is, 5.26 calorie per mole per Kelvin. So then what they are asking, temperature, T is equal to what happens, delta H by delta S it becomes. You will get the how much it is, 273 Kelvin it is. That is nothing but 0 degrees Celsius. Okay na? So next one, if 4.48 liter of an ideal gas at STP requires 12 calorie to rise the temperature. So 12 calories of heat energy is needed to rise the temperature by How much it is? 15 degrees Celsius at constant volume they are saying. At constant volume is nothing but what? Cv. Okay na? So we know that what here? Q is equal to N into Cv into delta T, it will be delta T. Now from this we know that what? Q we know. How much it is? 12. We don't know N value. N value we have to calculate here. So N value will be how much it is? We know that 22.4 liter is nothing but at STP 1 mole of a gas at STP. But they given 4.48 liter it is. 4.48 liter. How many moles it will be? It will be 0.2 moles it is. 0.2 mole. Okay na? So 0.2 into Cv into delta T is how much? 15. So how much it is? Cv is equal to 15 to the 30. 30 by 12. Okay na? So you'll get not 30, 3.0 it is. That is how much it will be? 12 by 3, it is nothing but 4. Cv is equal to 4 we got, but they are asking Cp. We know that Cp minus Cv is equal to R. From this Cp is equal to R plus Cv. Now Cp value they are asking in calories. R value in calorie will be 2. Cv will be what? 4. That is 2 plus 4 is how much? 6. Cp is equal to how much it is? 6. Is that clear? Now you see here, this question looks big, but it is very simple one. The enthalpies of neutralization of weak acid Ha and weak acid Hb. Though both are what? They given the what? Ha is one acid and Hb. Both are weak acids. Their enthalpy of neutralization with strong base is how much they given? Ha is how much? Minus 6900 calories per equivalent. It is minus 2900 calorie per equivalent. What they are asking? When one equivalent of NaOH is added to a solution containing one equivalent of weak acid and one equivalent of weak base, weak acid, that is Ha or Hb, the enthalpy change was, the enthalpy change is how much they are saying? 3900 calories. The ratio in which the base distributed between Hb and Ha they are asking. One equivalent of, here one equivalent of Ha and now here what they are doing? Ha, one equivalent of Hb. The enthalpy change was 3900 calories. The ratio in which the base distributed between Hb and Ha. We don't know how much it is distributed between the Ha and Hb. Ha you take it as x here. Okay na? So and Hb you take it as 1 minus x. That is x into minus 6900, okay, plus 1 minus x into minus 2900 is equal to how much they are given? 39. That is minus 3900 kilocalories. Minus get cancel every side minus. 2 zeros you remove. That is 69x plus 1 minus x into 29 is equal to 39 it will be. X is equal to how much you will get? It is 0.25. So 1 minus x value will be what happens? It is 0.75 it is. Which is this 1 minus x here? 1 minus x is nothing but Hb. Hb base. It is Ha acid. Both are acids. Ha and Hb. What they are saying? The ratio in which the base distributed between Hb and Ha they are saying. So the ratio between Hb by Ha. Hb is how much? 0.75. That is can be written as 3 by 4. It can be written as 1 by 4. It can be written as 3 by 4. Now 1 by 4 get cancelled. That is 3 by 1, which is nothing but what? X by y they said. X is equal to 3, y is equal to 1. Then what they are saying? X plus y is equal to how much here? 3 plus 1, that is 4. Is that clear? So different model questions which I had covered from the chemical thermodynamics. You can see complete chemical thermodynamics, all different model questions we had discussed. So you try to make a note of it, complete all the numerical questions. So don't neglect the numerical questions. You'll get the 20 marks easily. So I think so mostly all the first year chapters are covered. For more videos you can see in the description as well as in the iCard also. Okay na? Thank you. Have a nice day. Keep watching Appa Chemistry classes.